Hey guys, so this will be our last lesson in remote learning. We're going to look at the unit circle and try to be able to fill it out from memory so that we can use it to solve problems. There are three parts to the unit circle: degrees, radians, and coordinates. If we look at degrees, we started with this the other day. We know that on our x-axis is called our initial side. So if I go on that x-axis, this should be 0 degrees. So if I go up to the y-axis, remember that was 90, all the way over here to the other side is 180. So you can kind of picture that 90-degree angle. Oops, not sure why it's moving. Sorry about that. And then straight across, straight line is 180. If we keep going around, we would get to another 90 degrees, so that would be 270. And all the way around any circle is 360 degrees. Now, if I use what I know about fractions, I could cut this 90-degree angle right in half right here, and that would make 45 degrees. So 45, 90, another 45 would put me halfway here, and that would be 135. Another 45 past 180 would leave me to 225, and then another 45, either I could do 270, that does not look like a 270, 270 plus 45, or I might want to do 360 minus 45. That would give me this is 315. So all of these that are kind of halfway in the quadrants have a reference angle of 45 degrees. Remember, those reference angles are really, really important because they refer to the distance from the x-axis. And we're going to use reference angles a lot to help us memorize. So if I take away those blue lines, which will also take away my yellow highlighting, but that's fine, and I take this 190-degree angle here, and I want to cut it like this. Can you see the other fractions that are created? So if I take this, this is a third. So a third of 90 would now be 30 degrees. This one would be 60 degrees, and I could keep going around. So some of you are probably like, this is already too much, Ms. Robertson. You lost me. So you know I love my tricks. There are tricks for degrees around the circle. So if you cannot see these fractional parts, the biggest fractional part I would love to bring your attention to is, remember, half of the circle is 180. So if half of the circle is 180, half of a circle is 90, quarter is 45. The other part of that hopefully you can see is if you take the whole thing and you cut it in thirds. So now if I took this and I cut it in thirds, that would be 1/3 of 180 is 60, 2/3 of 180 is 120. But say I'm way over your head, which is most likely because I can't look at you in your face and see what is going on, how many eye rolls I'm getting right now. So really important grounding spot is that you know that you start at 0. Everybody knows that. You guys are brilliant. You definitely know that. Anytime you come across a big gap, you're going to add 30 degrees. And anytime you come across a small gap, you're going to add 15 degrees. So now remember, positive means we're going counterclockwise. So if I start at 0, this is a big gap from here to here. This would be considered big. So I'm going to add 30. Small gap, add 15. That brings me to 45. Small gap, add 15. Brings me to 60. Big gap, add 30. Brings me to 90. Just keep going. Big gap, add 30. Small gap, add 15. Small gap, add 15. Big gap, add 30. And some of you will see the pattern. Add 30, add 15, add 15, add 30. Add 30, add 15, add 15, add 30. So degrees should be pretty easy. If you need to rewind, watch that again. The trick is definitely a trick. You guys should be able to see the fractional parts, but when in doubt, use the trick. Anytime you get to a big gap, add 30. Anytime you get to a small gap, add 15. All right, let's look at radians. So radians, remember, if you have degrees, any degree, so let's say I'm looking at 30 degrees. We already learned how to go degrees to radians. If you missed that video, you're going to want to watch that. That was last Wednesday and Thursday's lesson. So if I'm at 30 degrees, remember pi equals 180. So I could write pi over 180 is really just a form of 1 because it's really just 180 divided by 180, or you could think of it as pi over pi. So if I have a degree, I'm going to multiply by that pi over 180. The division will undo this degree here. It's just like those conversions you do in science class. So 30 and 180, well, 30 goes into both of those. 30 goes into 31s, 30 goes into 186. So this would just be pi over 6. If you want to use your fractional parts, so you can, some resources say if you add these extra lines here, so those red lines that are there are not really part of the unit circle, but if you add them, you can see that really you're just going up by 15 degrees because they cut those big gaps in half. So we're just 15 degrees, which is the same as pi over 12. I would much rather you guys use the fractional parts here. So let's just look at our fractions. If I know that all of this is 1, so that's the most confusing part, is that we're so programmed to think of a whole circle as 1, but this is actually 1 whole. So if I take that and I cut it in half, this now gives me a half and a half. So right here at 90, you can see the pi over 2, half of pi. If I take those half pieces and I cut them again in half, I should see quarter pieces. So now I took my whole and I split it into fourths. So here is 1 quarter. I would have 2 quarters, which reduces to 1/2. 3 quarters, so 3 pi over 2, and then 4 quarters. 4 over 4 is really 1. So that's how I could use my halves and my quarters. If I want to look at the other pieces, so I'm just going to get rid of all of these for a second. I'm still going to keep my ground that this is a whole, so I still have my 1 whole here. If I take my 1 whole, and this time I want to divide it into 3s, that would look like this. So now I have a third, this is another third, this is another third. So when I look here, this is what I'm talking about. If I cut this whole here, I have 1/3 pi, 2/3 pi, and now I'm looking at 3/3 pi. 3 over 3 is still 1. If I want to take that and cut it even smaller, so now I want to cut my thirds in half, that would make pieces that are 1/6 big. So let's take a look at that. So I would have this one, 1/6, 2/6, 2 over 6 reduces to 1 over 3rd, so that would be 2/6. Cut this again. This would be 3/6. 3 over 6 is the same as 1/2, so pi over 6. 4/6. 4/6 is the same as 2/3, so 2 pi over 3. And then this would be 5/6 pi, 6/6 pi. The same thing happens below. So I know I'm not continuing this, but if I were to follow this, okay, here's my thirds. So remember I ended at 6/6. I want to make the thirds in half, so that would give me this. So 7/6, right? This would be 8/6, which reduces to 4 pi over 3, 9/6, 3 pi over 2, 10/6, 5 pi over 3, let me just shade it, sorry, 11/6, and then 12/6 would be all the way around 2 pi. Again, if that is over your head, so let's say I lost you again. I'm sorry. I know it's so much easier when I can actually look and rewind what I'm saying. You can rewind this and rewatch this, but if you get the degrees, so as if you can do big gap, add 30, small gap, add 15, small gap, add 15, big gap, add 30, big gap, add 30. If you can do that all the way around, then just remember, if you have a degree, any degree, you can make it a radian by multiplying it by pi over 180. So pretty much in your calculator, take your degree, divide it by 180, hit math fraction if you don't want to think about reducing. As honors kids, you guys should realize 60 over 180 is really just 1/3. And then you need to put back that radian, so that pi has to go back. 1 pi over 3 is the same as pi over 3. So 60 degrees, pi over 3. That will work for any of these. So we know that this one down here is one big gap away from 360. So this would be 330. And I can do the same thing. 330 divide by 180, math fraction gives me 11 over 6, and then I'm just going to put my pi back, so 11 pi over 6. Remember, you can also email me if you have questions or come to office hours. I'd love to see more of you at office hours. All right, so coordinates. Disclaimer, this will give you guys a headache, but I will show you a trick in a little bit. There is a reason why we started with special right triangles. The unit circle is just special right triangles. So we need to find all of these coordinates around the unit circles because they represent really cool things, which I'll show you in a minute. So if it's a unit circle, big idea here is that the radius is 1. So if my radius along from any center to the edge is 1, I know that this is 1, 0. This is over 0, up 1. This is left 1, up 0. And then down here would be over 0, down 1. So those 4 points should be kind of no-brainers. Unit means 1. So unit circle has a radius of 1. That is a very, very big idea. So if I want to find the coordinates that are 30 degrees away, so here is my 30 degrees and my 1. I can use this special right triangle. So I just took this piece and I'm going to just look at it separate. So this is 30. This would be my short leg. 30, 90 leaves me with a 60. This is my hypotenuse. And then this is my long leg. So remember, our short leg is half of our hypotenuse. So this side is 1/2. And that happens because if I have this 60, 60, this should be a triangle, 60 here, all I did was cut this by a perpendicular bisector. So if this is 1, this is half of that other side from the equilateral, so that becomes 1/2. So now I could use a squared plus b squared equals c squared, or I could use the rules that my long leg here is my short leg square root 3. So 1/2 times the square root of 3 is just square root of 3 over 2. So essentially, this triangle here, this side is 1/2, and this side is square root of 3 over 2. 1/2 times the square root of 3, just cleaned up a little bit. So if I want to name this point, in other words, I'm looking at a graph, and I know this is 1, 0, but I'm asking you what this point on that graph is. So if you were reading me this point, you'd say, well, Ms. Robertson, it is over this amount. Well, this amount right here is rad 3 over 2. So my x coordinate here is rad 3 over 2. This point is up that amount. So it's actually up this amount, which is that side of the triangle, 1/2. It is the same as if I gave you just like a normal graph and I said, hey guys, what's that point? You'd say, well, that's 3, 2. You went over 3, up 2, over 3, up 2. This one over rad 3 over 2, up 1/2. So all along your x-axis, if I use my reference angle of 30 degrees, every single point that's 30 degrees is going to have those same coordinates, except for we know that in quadrant 2, it's going to be a negative positive. So when I fill this out for quadrant 2, it's just going to be negative square root of 3 over 2, 1/2. In quadrant 3, x and y are both negative, so this point is going to be negative square root of 3 over 2 and negative 1/2. In quadrant 4, x is positive, but y is negative, so my coordinates would be rad 3 over 2 and negative 1/2. All I'm doing is using that special right triangle of 30, 60, 90. I hope that makes sense. If I want to use the reference angle of 45, that puts me at these points that are halfway between each quadrant. So I'm looking at this 45, 45, 90 triangle. My hypotenuse is 1 because I'm in the unit circle. So I could do a squared plus b squared equals c squared. And I could solve that to get what x is. You can also use your rules. So our rules are that your hypotenuse, is your leg times the square root of 2. If I want my leg, I'm going to do hypotenuse divided by 2, square root of 2. So if I take 1 divided by 2, square root of 2, that's essentially square root of 2 over 2. If you are using the a squared plus b squared equals c squared, you would get this, and then you would need to rationalize your denominator, meaning just multiply it by itself. But all that's saying is that if I'm here and I need this point, along this x-axis is rad 2 over 2, along this y-axis is rad 2 over 2. So every point that's halfway has those coordinates rad 2 over 2, rad 2 over 2. The only thing that changes are the signs. So remember, in quadrant 2, x is negative, y is positive. In quadrant 3, they're both negative. And in quadrant 4, only the y is negative. So that's how I get the middle point. The third point has a reference angle of 60. So even when I'm over here, this is really 120 degrees. If I'm thinking in reference to my x-axis, remember I would come back to this side because the shortest distance is actually coming down, and I do 180 minus 60, still gives me a reference angle of 60. So I'm taking that same triangle that I had with when they were red that we started with, but now the short leg is down here, so this side is 1/2, and the long leg is here, so that's rad 3 over 2. Unit circle always has a hypotenuse of 1. So essentially, I'm just flipping. So now this is 1/2 rad 3 over 2. It's the same way for every reference angle of 60, except for my signs just change. All right, so I hope that that makes sense. So that's how you can get all of these coordinates in the unit circle. And don't bother copying that down yet because I am going to talk a little bit more about that. So let's just look at these triangles a little bit more. If this was a triangle, which it is, and it's a right triangle, the second lesson we had you guys do was SOHCAHTOA. And we had you do SOHCAHTOA so that if we are using this as a reference angle, and I asked you guys to find the cosine of theta, you would say cosine is co. So cosine of theta would be this is opposite, this is adjacent, and then this is hypotenuse. So I'd say adjacent, which is x over 1. Well, anything divided by 1 is just itself. So cosine is always your x value, which means now when I'm looking at the unit circle, if they ask me cosine of a value, it's just whatever the x coordinate is. Same thing for sine, well, similar. So sine is so I would do y over 1. Y over 1 is just y. Tangent, TOA, I'm going to do opposite over adjacent, so y over x would end up just being sine over cosine. One more thing that shows up in Math 3 that really at this point you just have to understand where it comes from. If I have any right triangle, remember that I could do A, B, and C, and A squared, sorry about that, guys. A squared plus B squared always equals C. Well, in the unit circle, our A, I'm just going to put in as x squared, B, y squared, C, since it's a unit circle, is 1, and 1 squared is 1. So I don't actually like how that is. This should, if I started with x, it should really say cosine squared theta, sine squared theta equals 1. But you will see it in both of these ways. And in pre-calc, those of you going there, you will do a lot with trig identities. So this trig identity is called the Pythagorean identity. So I just wanted to show you that. All right, who's ready for a trick for these? So first trick I want to show you, you know this from 6th or 7th grade, depending on when you learn quadrants. Quadrant 1 is positive, positive, negative, positive, negative, negative, positive, negative. So if I go through, I know that if every coordinate, my x is my cosine and my y is my sine. So I have cosine, sine. It's nice that x comes before y in the alphabet and c comes before s in the alphabet, so just keep them alphabetically. Tangent is going to be sine over cosine. So this one would be a positive divided by a positive, which is a positive. This one, if I did tangent, I'd do positive divided by a negative, which is negative. Tangent of this one would say a negative divided by a negative, which is positive. Tangent of this one would say negative divided by a positive. Well, that's negative. So there's an expression. If you go through the quadrants, so you can think all students take calculus. That's not necessarily true. I actually stole another expression that I heard Mr. Ruger say. He uses Alvin, Simon, Theodore, and some of you might pick up that I'm talking about the chipmunks. So Alvin or all, whatever you want to remember it as, is just saying that all trig functions are positive. Cosine's positive, sine is positive, tangent is positive. Simon or students, only sine is positive. So cosine is negative, tan is negative, only sine is positive. So let's just circle the positive ones here so you can get the gist. Theodore or take stands for tan is positive, so cosine is negative, sine is negative, making tan positive. In quadrant 4, cosine is what calculus and chipmunk stands for, so only the cosine is positive. Sine is negative, and a negative divided by a positive makes tangent negative. So how do I use this? Actually, sorry, what's the trick? Okay, so we always go from the x-axis. That's our initial. We talk about our reference angle. So if you're going from the x-axis, so I'm just going to start here. My x coordinates, I'm going to write 3, 2, 1 going up. Then my y coordinates, I'm going to write 3, 2, 1 going down. All of my bottoms are 2s, so I'm going to put 2s on all of the bottoms. All of the tops are square root. So I wrote except 1 because the square root of 1 is just 1, so we do not write the square root of 1. So that's the one, so I'm going to leave it. And then all of these are going to get square roots, and then I'm just going to put my comma and my parentheses. Check your signs. So quadrant 1, they're both positive, positive, positive. Notice I'm not doing the ones that actually land on the axes. You guys should understand that if this is a unit circle, this is 1, 0. This is over 0, up 1, left 1, up 0, over 0, down 1. Those should be really easy. Let's look at another set. So I want to come from the x-axis. This time I'm going to do the ones in quadrant 3. So from the x-axis, x coordinate up. So I'm going to go 3, 2, 1. And by up, I just really mean away from the x-axis. So I guess I should say away. And then this one would be towards. So now my y coordinate, I'm going to count back down, 3, 2, 1. All of my bottoms are going to be 2s. And then all of the tops, except for 1s, are going to be square root. Check your sign. So in quadrant 3, everything is negative. And we do want to write those negatives outside the square root because remember, you cannot square root a negative and get a real number. So if you write the negative inside, that's definitely wrong. All right, maybe one more. So what do you guys want to do? We'll do quadrant 2. So from the x-axis, so I'm going to start here. I'm going to do my x coordinate, 3, 2, 1. Back down, 3, 2, 1. All of my bottoms are going to be 2s. All of my tops, unless they're 1, are going to have a square root. And now I'm just going to check my signs in quadrant 2. The x is negative and y is positive. Might as well do quadrant 4. So from the x-axis means I'm starting here. I'm going to do my x coordinates 3, 2, 1, then go back for my y coordinates 3, 2, 1. All the bottoms are 2's. All the tops are square roots, unless they're 1 because the square root of 1 is 1. And then since I'm in quadrant, 4, silly me, the y is going to be negative. So x is positive, but y is negative. So I have square root of 3 over 2, negative 1/2, square root of 2, rad 2, negative rad 2 over 2, 1/2, negative square root of 3 over 2. All right, so if you did not fill out your complete circle, you might want to just pause this here and make sure you have everything. Although, guys, if you Google unit circle, there is so much out there.